Live from New York, it's Ask an Engineer.
Hello, and welcome to another fantastic, slightly less echoey maybe, Ask Engineer. We have this nice microphone now.
Yeah.
We're broadcasting live from the still mostly empty ex-Adafruit headquarters, where we'll be here for another 60 days or so.
That's right.
We've got a jam-packed show. Tell them what's next on the show.
All right, on tonight's show, the code is next. We're going to be showing off a special project that we did. Lots of fun, retro hardware, and hacking with modern electronics. We got the show and tell. A bunch of folks showed up, showed off some very cool stuff. We've got mailbag. We've got a new wonderful thing in the world of community, Adafruit on Google Plus communities. We'll talk about that more. We have Makey Monday. So have some open source hardware news, some Arduino projects, some things from the Adafruit learning system. We've got Wearable Wednesdays. We've got 3D Thursdays.
Friday's Pi Day.
Friday's Pi Day. We've got new products.
We've got new people.
We've got new people. We've got your questions, trivia question, all that and more, and a cat, all on Ask an Engineer. Okay. So here's the put the cat down.
No,
it's distracting.
he jumped on my lap.
He wants to be on the show too early.
I know.
Yeah. All right, so we decided to, we're finally getting a little bit of time. The holiday season is over.
Yeah.
It's
interesting, right? Most people think the holidays start like in a few weeks, but actually they're done for us now because like everyone's nearly done ordering things that they want, and orders are starting to slow down a little bit, and
yeah.
We're wrapping up a little bit the year.
Yeah, so the big holiday rush is pretty much over. So I had a couple minutes, and one of the things that we're doing in 2013 is giving Ask an Engineer a really big upgrade. We're going to be in a real studio.
Wow, wait till you guys see this new studio.
Yeah, we have a studio. We have all sorts of stuff. But tonight was a little bit of a test because I wanted to have a different microphone. We're here, it is empty in here. All there is our few possessions in boxes and your EE bench. And so there was an echo. So this week we wanted to try this out. It sounds like it worked a lot better. So thanks for hanging in there, everyone who, was either that or not do the show. We wanted to keep doing the show. Sorry about the echoes in the past. So, anyways, tonight's code is next.
Now, you don't actually have to have it spelled like that, though, right?
You don't have to have it spelled like this.
It's
the
okay
code next.
if you forget the
just the code next. We have a lot of stuff. At the last second, I remembered that I didn't put the news section in, so I'm going to have to jump around a little bit, but that's okay. Let's first go to the show and tell. Every week we do the show and tell on the Adafruit Industries Google Plus page.
Sure, I'll tell them. Let's go through it. Okay, so first up we had Jay, and he came back with his solar tracking thingy and revolver. He had this big motor, and he was controlling it with an Arduino, and he was detecting like the sun power. And then he used a GPS to figure out what his latitude and longitude was, and then calculate where the sun position is based on the time, and so we could track the sun. Jenna, who did this kind of neat mega bicycle project, which we had posted on our blog, it used an LED matrix to do like left and right and stop buttons, and she wants to put an odometer on there that tells people how fast she's going, and maybe a sonar that tells people not to be so close and all that good stuff, so that's cool. Nice, Jenna. You can check that out on the blog as well. Oxypo showed up, his first Arduino internet project. He used an Ethernet shield to control some LEDs. It's a really good beginner project, and he wants to write an iPhone app to learn how to do iOS development, which is cool. And then Brian B showed up, and he's writing a robotics Raspberry Pi book. And he kind of hacked this old toy, and then he talked about like this old animated TV show, and then we chatted about Raspberry Pi and robotics, and it was kind of weird. Yeah. If you would like to show something fabulous on the show and tell, super easy. Please go to the Adafruit Google Plus page. It's plus.google.com/+Adafruit with the plus sign. And look for the post where we say comment here to get added to the circle. We'll add to the circle, and then you can show anytime in the future. And if you show something on show and tell, you get a fabulous sticker. To get your sticker, email support at Adafruit. That's right. All participants get a free show and tell sticker. We've been seeing these on projects. And for Brian, who is writing the Raspberry Pi robotics book, we're going to send him a servo driver. I already have the code written for it. So how many servos could you be running with that, or motors could you be running? You can drive up to 992 servos. 992 servos. And that would be really cool, but the most I've seen so far is, I think 50 servos. The person who did the the servo-controlled piano.
Yeah.
They had one on every key, and that was about 50 servos.
Maybe 50 is the max they've seen with our board?
So far,
Yeah.
50.
Okay.
But I'm holding out.
Okay.
I think somebody could drive 200 servos.
Okay.
That'd be cool.
Let's tear through these. We've got some news.
Mailbag.
Well,
Nope.
no, we're
Sorry.
gonna skip through to the news. I just have to find the news.
News, I think, is down here.
Yeah, it's all over the place. So there was Maker Faire Tokyo that just went on during the week. We covered it on the site. Ian Lesnick from Dangerous Prototypes had some awesome photos. I just want to show two. This one is the
That's our badge.
this is the Gita badge from Adafruit. So people who are
Nice.
learning an open source CAD tool have badges, and we give money for all the ones sold to the folks who run Gita. But that was one of the other things that he took a photo there that I really liked was the embroidered Next motherboard.
This is like the theme of the week.
Yeah, Next is the theme for all sorts of good reasons.
That's
we'll
why
get
the
to that
code's
soon.
Next.
Yeah, that's why the code's Next. And then this was like a Cronenberg film, but it's actually and then I wanted to go through some other things. On the 15th, the toy hacking event is still going on. So they added one more day. John Junior posted up, due to overwhelming interest, a third Hacking for Holidays soldering workshop has been added for December 15th. Really cool event where toys get modified to help kids that have some type of challenges with small buttons or operating toys, just making toys more accessible for everybody.
Yeah.
So I think that's really cool. Also, you learn some interesting skills. Like I know a lot of parents who want to lower the volume of certain toys or maybe take out a speaker.
Yeah.
Or maybe add one.
Or add more flashing lights.
Yeah.
Okay, cool.
So next up, like I said, I'm going to have to skip around here. On the Arduino, I'm sorry, on the Wired Italia website, they did a 30-minute documentary on the Arduino project. It's all Italian, but with English subtitles. And it's from Massimo being on the cover. Massimo, one of the co-founders of Arduino. And it's a beautiful story about how he got his start and where the Arduino inspiration came from. And if you look really close, you can see some factory shots. And it was beautifully made. So we posted up on our site, and we also had it.
Massimo's on the cover of Wired Italy this month.
Wired Italy,
So
yeah, and he has a big wrench. It's very cool.
I like it.
And then
That's what he uses to smash Arduinos. I don't know.
also this month is December. It's for the STEM, science, technology, engineering, math, and it's presented by Girl Start. There was some interesting news in the world of maker business. And I'm just going to try to find it here. So Apple announced that they're going to have a line of Macs made in the USA or assembled in the USA.
Yeah.
Maybe this new Macs. It was really it's interesting for us because people think we're crazy for having a pick-and-place machine, a reflow oven, and doing manufacturing in the U.S. I remember there was like some forums, and they're like, basically, Adafruit is stupid. They should outsource everything to China. And we decided a long time ago, let's get really good at manufacturing short runs right here in the U.S., and maybe let's work with a local partner if we ever need to do assembly. But the time it takes to go back and forth for China, for us, would be a deal killer. We like to design hardware, get the prototypes, and then make 100 right away. And get it out in the market, and then make 1,000, and then after 1,000, we'll talk to other companies in the U.S. who may do assembly. But what's interesting is if you read the article and this interview with the now CEO of Apple, they're basically saying we need to get this stuff faster, and inventory is like milk; it spoils, and so you have to get it closer to the stores. It has to be sold within a few days. And if you look at the finances of a company like Apple, all their revenue comes from products that were only released, 90 days ago.
Yeah.
Like that's how quickly it happens. So it'll be interesting to see what happens in the next year. So we have our series called Maker Business on Adafruit, and there's a bunch of made in USA. Everybody's now talking about this.
Yeah.
So we'll see. Maybe we're not so crazy.
I don't think. It's an interesting story, though.
Yeah. So that's happening right now. And we have to get an iMac for our video editing, and we're gonna only get one if we can request. It's one of the USA ones.
That'd be cool.
Yeah, we'll see how it goes. All right, next up, just some housekeeping here. You're going to be at the ITP Women's Entrepreneur Festival, January 22nd, 23rd. You're going to do a little talk on a panel.
That's right.
That's cool. There is a Adafruit mention, you and Becky did an interview with John from NPR and also Spark with Nora Young, and it was about the badging system.
That's right. We talked all about badges.
Yeah, all about badges and kids earning badges that have nothing to do with the Boy Scouts or Girl Scouts.
Yeah.
It's modern badges for modern maker skills like laser cutting and 3D printing. And they also featured DIY.org, who's also doing a badging effort. These are their badges. They have these neat kind of hexagon badges that go together. Yeah, they're really beautiful. So we really like seeing all these badging efforts. We have our skill badges. You can go to adafruit.com/badges. We have physical ones and digital ones. So it's really neat to see that. All right, next up in the news, we had a new person join our team, Molly. Adafruit has a chief operational officer now.
Molly.
This is Molly. Molly was in the rain.
No, she's like at the top of a mountain.
Yeah, it was like windy and cold. And Molly's hobbies are photography. You can read the intro post about Molly. She took this, I believe, during the blackout.
Yeah.
The Sandy event.
She likes night photography.
Yeah, and now we're able to do more as a company, have more people in the team. Molly's known Becky, our director of wearables, for like 25 years. And so that's pretty cool.
Yeah.
Molly comes from a architectural background, managing really big projects, and so when she started working with us, we're like, wow, this is the type of person we need as Adafruit kind of goes to the next level. We have 12,000 square feet in our new factory. We're looking to even get more, and so we need someone who can kind of come in and help us run the show.
Yeah. Full space.
Yeah. Anyways,
it's no longer something you can control with an arm's length, you know.
Yeah, and you'll see Molly's post on the site, and you'll see a lot of her stuff in the world of Adafruit. Okay, next up in the news, there was a really cool article that the folks from Siftio, specifically Beth, posted up, and maybe you can talk about this because it is probably one of the best EE reverse engineering stories I've heard.
It's forward engineering.
Yeah. And so maybe while you talk about this,
you want to play with these cubes?
Yeah, I'm gonna play with the Siftio cubes while you discuss this.
Okay.
And go ahead and tell the story. What was this article about?
Well, I'm going to talk about it in general because I didn't write the code, but it sounds like the original Siftio cubes, which you're demoing right now, they required a computer and they used like Bluetooth or something similar to communicate, or make NRF 2401 or some 2.4 gigahertz type thing. And so you need a computer, which is okay, but then you have to carry your laptop around. And they wanted to make it so, first off, they wanted to reduce the price. And second, they wanted to have more processing occur, I think, in the cube so that you didn't have to have like a full powered computer that basically used the cubes as a display. And so what was interesting is like, you want to go as cheap as possible. You want to pick a processor that is low cost because, if you can get a really inexpensive processor that can do everything you want, that can cut your price by like $10 because like, a very fast processor $8, but like, if you can get away with like $1 processor, that's even better. But the trick is you don't want to go down the development path too far where you spend all this time and effort writing all your code and you have to optimize it for this processor, but then the processor isn't good enough to handle like the full screen video that they're doing here with these little like 128 by 128 TFTs, or it can't do the sound or can't interact in time. And so I think a lot of it was about, how to analyze and emulate the processor. I guess it's based off of an 8051 core. And so like using an 8051 emulator allows you to see like how slow can you clock it while still maintaining this kind of Super Nintendo style video. And so this chipset was apparently originally used for making a wireless keyboard. So I think it's kind of interesting. When you go into production, especially when you're making toys, like every dollar counts. You have to shave as much money off the cost of the bill of materials. And bill of materials like to balloon. They like to get really big, and so you have to work really hard to make it cheap. And then this is one of the things that we work on at Adafruit too. I mean, we're not making a finished product like this, but we just have to figure out like can we run the processor at 8 megahertz? Like we were working on the Times Square watch. Like we were like, what is the cheapest processor we could get away with, and like how slow can we clock it and still maintain the video quality? And Paint Your Dragon, spent a lot of time trying different bit depths and scan rates to see, like, what can we get away with to reduce the power consumption, reduce the clock speed, and basically reduce the extraneous component costs. So that's actually what engineering is really about. Like, I think a lot of people assume, like, oh, engineering is about building something. Well, no, not really. Like, anybody can build something, right? The trick is, can you build it to a specification? And this is a really good example of spec work where she had to get a specification of, like, get this to be, like, under $10 in cost. And she's like, okay, how can I do that and do that without losing too much time, because we have to get to market really fast.
Yeah.
And they got these out before Christmas, which is like the deadline, right?
Yeah.
It's always
we bought a set. Someone asked what that the other black box is. That's the base station.
That's the base, yeah.
And that's where the sound is, and you can plug that to a computer and download more games into it.
Yeah, so they don't have little speakers inside of them,
Yeah.
which kind of makes sense, and because like there's not a lot of space inside. And so this is the base, and so this is actually this is an ARM3 chip. So this is actually a little bit better processor, and this handles the inter-chip communication. But you still need quite a bit of processing on these guys in order to paint the display and also do this bidirectional communication. And you want to have enough memory that you can display like animated graphics. I mean, like, I've done enough graphics on an Arduino node. It's actually really hard because you often don't have a full frame buffer, right? A really good chip has a separate RAM chunk that you can address specifically for your frame buffer, so you can like edit each bit in the frame, because like you do the math, you take 128 pixels by 128 pixels, and each one has 16-bit depth, and like. So to buffer that is actually a lot of space, and really cheap displays, like sometimes they have the memory built in, sometimes they don't, and then can you access it fast enough? And then, if you want to do animations, how can you push that fast? Like it's
she talks about the kind of looking at what they did at Nintendo with the Game Boy, and this is a wireless Super Nintendo. It's kind of funny, like that's kind of what it is.
Well, they figured it out. I mean, like, and another thing that's interesting, if people are interested, is looking at the fuse box, which is a 16. Actually, it's overclocked. It's like a 25 megahertz at Mega 64.4. So it's like, and that's mostly because we wanted a lot of RAM to buffer these tiles. But it's like all using Flash for tile spacing, and you can actually have like a Nintendo. Yeah. Play games on it.
Okay, so do check out that article. It made the rounds everywhere.
Yeah.
But if you haven't checked it out, it's a long read.
It's cool technology too. It's very magical.
Yeah. Get comfy. It's an excellent read.
It's a good article.
Okay. Next up, we have some more things that we do each week here at the Adafruit site. We have Packet the Mailbag. This is letters from...
Mailbag Thursday.
Yeah. Adafruit folks, thanks for your great support. My son Ice 2 Clock works very well. He is so psyched. Hopefully he will get up on time. Of course he will. We tested the alarm. Cheers and keep up the good work.
Okay.
Yay, that was very nice. One big thing that changed this week for us is Google said, hey, would you like to be part of this Google community effort? We're going to launch it very soon. And we had to quickly make a new section on Google Communities for Adafruit. And we decided to not just say this place is all about Adafruit. What we wanted to do is be a little bit more general. So it's called Makers, Hackers, Artists, and Engineers. And it's a place where people can share all the things they like to make and all the things they like to learn.
I like all the projects people started posting, like, here's what I'm working on, here's my workbench, and like we had a roll call. Yeah. And that was kind of fun.
Yeah, and we're learning a lot, and Google featured ours, and so we're in a short list of folks that are pretty interesting brands to start off with. So Star Wars is in there. They have a community. National Geographic, their community is about exploration. Space, about space. The photo community. And then, yeah, and so this is our page. If you go to the Adafruit site, we have a post up about it. You can join up if you happen to have a Google account. And we'll do some special fun stuff there, just like we do the Hangouts now. They're all kind of wrapping it together. I'll have to say, as a company that manages content and support and just about everything in products, this is a very unique tool. Yeah,
it's interesting. I mean, right now content is flying by so fast that you can't really keep up.
Yeah,
there's so many.
Yeah, everybody's coming in right now, and so there's thousands of people a day. So it'll settle down eventually. But right now it's neat because people are just coming in and posting links to their projects. Speaking of, this person just posted up their project right before I got on the air. This is their Tesla Christmas tree. Yeah, isn't that neat? So I've seen lots of photos, but this one he put up right on our community page. I thought that was really cool. Next up, we have a segment, a series every week that Matt does, speaking of community, called Makey Monday. And this is a cool product developed by Jay and Eric at Joy Labs. And this week, I wanted to spotlight a special video that someone made using a Makey. Okay, so that was someone playing flowers with the
I
Makey.
like the use of like, the water as a conductive element.
Yeah.
That's kind of
So all sorts of cool musical instruments that you can make with a Makey. So very cool. Every week we do another new thing on our site, and this is Scenes from Manufacturing in Adafruit. We're trying to share all the cool behind-the-scenes stuff. And this week, when we were doing these pixels, these are all the LEDs that are controllable for the Flora. And after we test them and separate them, someone on our staff said, hey, these kind of look like snowflakes. So, of course, first thing we did was make an animated GIF of this. So this is Flora pixels after they're tested and right through production. So
cute.
Yeah, look at this pile of LEDs.
That is, well, we had to make 800.
Yeah.
For 100 packs of Flora.
Yeah, so just for the folks who don't know about Flora, Flora is our new wearable platform, Arduino compatible. It's sewn onto jackets or whatever, a fabric. It has snaps that we can do cool stuff with. But the goal is to make wearable, or one of the goals is to make wearable LED jackets. So you could wear a movie. And so we have to be able to make thousands of these LEDs at a time.
Yeah.
So that's why we have a big pile of those. And we sell them.
Jones is part of that.
Yeah, Jones our reflow oven as part of this. Okay. Let's jump over to the Adafruit Learning System.
Okay, yeah. We got news,
Adafruit Learning System this week has a ton of things. First up, there were some updates on the Adafruit Learning System. The first one being there is now related guides. So if there is a guide that has something to do with something like Arduino, it'll have a related guide.
Yeah, or like for example,
like
if you're reading a guide that uses like our microphone amp, it'll try to suggest other guides that use our microphone amp or other components like it. So it'll try to figure out what's similar.
Yeah. So new features this week: ability to have multiple headlines, related guide feature, homepage popular feature, fix products causing page redirect, fix sidebar scrolling issue, adjust alignment of sidebar, regenerate new product images with each new width, and we fixed a side-to-side display. So right now we feel really comfortable with this being a solid release. We're going to do a few things behind the scenes, but it's getting a lot of traffic. A lot of people are using it. And we're really happy with it. So if you haven't already, check out learn.adafruit.com. Speaking of, here's the new tutorials for the week. So you'll probably want to talk about this one.
Okay.
This
is really cool. This is a tutorial that Phil B did, and it's for the Times Square watch, which I can maybe show here. So we made this fun watch. And to make this watch work real well, we wanted to get the best battery life out of it. And so we used a microcurrent, one of the really cool low current measurement devices that we carry by the VEV blog, Dave Jones. Okay. And it works really well, but one of the things is it'll tell you the current drop. It doesn't tell you how long the battery will last. Like, we wanted to know how many times can you click the button and display the time before the battery dies, which is a different thing than how much current are you drawing, because like current draw and battery life is nonlinear, and like, it sort of depends on how often you click the button. And so we wanted to have an Arduino with a data logger shield to measure the battery voltage to see like how many times can you click it before the battery voltage dies and it doesn't turn on anymore. And so we got like a couple hundred clicks, and it helped us figure out like not only like how to adjust the battery current, but like make the life longer with the battery. And so Phil B did a really interesting write-up about how he did that and how to avoid one of the side effects that is very confusing for some people, which is they'll end up using something, a measurement tool that injects current into the project, because when you're running at like microcurrent levels, if you had a pin that's from an Arduino that's toggling something on the target, that can inject current in, and so you'll get longer lifetime than you would have. So we have to figure out how to do that in a way that we didn't end up accidentally powering the circuit from the tester, which is something you just have to watch out for. And so he put some notes down about that. He put some notes about using the brownout detect. It's a nice little write-up, so if you're doing a low-power project, check it out. Very, very handy notes.
Okay, next up, a lot of Arduino tutorials from Simon Monk. So
Dr. Simon Monk.
Dr. Simon Monk. Do you want to talk about which ones these are?
This is pressing buttons to light up an RGB LED. This is lesson number 7, I think.
Yeah, 6.
Yeah. This one is using 74HC595 serial to parallel latch to control 8 LEDs without having to use 8 pins.
Okay.
This one is I think lesson number 4. This is like how to use buttons for an input, and so this one allows you to turn an LED on and off using 2 different buttons. And this tutorial is about how to use the serial monitor to debug your project. And this is just how to control an RGB LED. Basic, very basic. And I think this is lesson number 2. This is just like blink.
Yeah.
And this is lesson 1. This is blink without even a breadboard. This is like ultra early blink.
And then another one, we're starting to have customers and people in the community submit their tutorials to us, and we're adding those into the learning system. We'll have a special tag soon. But this is from the show and tell from a week ago. This was the reverse geocache project from Kenton, and he made this beautiful box that when his fiance found the box or went to a certain location and opened up and there was a ring inside of it, and then he asked her to marry her, she said yes. So that tutorial is on learn.adafruit.com, and you can see how he made it.
Yeah, it uses a lot of Adafruit stuff and some stuff that isn't, and then it's like a custom box.
Yeah.
And so like this would be a really great demonstration of how to use like a permaproto and the GPS and the LCD all at once and a servo. Like this is, a lot of people ask us, we have tutorials for each item, but there's like infinite combinations, and sometimes we don't get a tutorial that combines every single product the way some people want. So this is really nice. I like how this combines a lot of different items together.
Yeah. I'm going to hold off until there's a new one in the learning system, but we'll get to it in a second because I'm actually using that as my keyboard tonight. So I'm going to skip ahead to Wearable Wednesday. Every Wednesday, Becky and folks from the Adafruit team post up a ton of wearable electronics projects, and this is all around our new product, Flora.
Well, some of it is. Some of it's just like cool
stuff.
stuff.
We just want to show all the things that you can do. And of course, like Flora is our thing that we have that is now in the wearable electronics category.
I like this one. This is the fascinator. This is so cool.
Yeah, this is really neat.
I love it.
An EL wire head.
It's got a little bit of that like Burning Man aesthetic, but it's still kind of funky and cool, and it makes me think of Las Vegas a little bit. Yeah. But in like a good way.
And then
also it looks a little bit like a Choluli art piece, like a little like a blown glass Choluli art piece on your head.
Yeah, it does.
But without having to be like really heavy and cost $10,000.
It's like I'm wearing a piece of the Bellagio.
Yeah.
And then, like I said, this is kind of the day that we celebrate Flora. And Becky this week showed how to make this beautiful Flora brooch, this RGB LED brooch. So
watch the video?
Here's a video.
Let's watch the video.
Here at Adafruit, we're really excited about the launch of Flora, our wearable electronics platform that's Arduino compatible. And today I've got a project to get you started with no soldering. It's this LED brooch, and it uses our Flora RGB smart pixels and some freehand wiring to hook it all up. Let me show you how to do it. You can use almost any kind of wire for this project. I'll be using this solid core hookup wire, and I'll use wire strippers to remove the insulation at one end, although you can also use completely uninsulated wire for this project. Insert the wire into the hole marked D6 on the Flora and wrap it around to make a tight connection. Wrap the wire around itself a few times and cut off any excess to make a nice tight connection that doesn't wiggle. Repeat this process for the pin marked G and D for ground, and then add one more wire at the hole marked VBAT, which is the voltage coming out of the battery. Don't forget to check out the tutorial for this project on the Adafruit Learning System, which includes a fancy wiring diagram. Now you have 3 wires connected to the Flora. The ground and power wires will remain long, connecting between all 3 of the pixels, but the center wire you should cut short to connect to the first pixel's input. This is the pin marked with the little inward pointing arrow. The pixels will chain together and are individually addressable, meaning you can tell each one to be a different color if you like. If your wire is insulated, remove the rest of the insulation from the remaining section of the power and ground wires, but don't cut them because they'll connect all 3 pixels together. The pixels in the Flora were designed to work together, and the pins you'll notice are all in the right order: ground, signal, and power, marked by a plus sign on the pixels, and the ground is marked with a little minus sign. To add a second pixel to your chain, use a new wire to connect to the outward pointing arrow on the previous pixel. This will connect to the inward pointing arrow on the next pixel, and so forth. As before, connect the power and ground wires to this new pixel. Repeat this process for as many pixels as you'd like in your design. Electrically, everything marked ground or with a minus sign is connected together, so if you're looking for a little extra wire stability for a design that wraps around the Flora, you can connect another wire to the ground pin on the Flora and connect it to your minus sign on one of your pixels. There. It's pretty nice, stable, not wiggly. Next, plug in your USB cable. You can download the Flora software from the Getting Started with Flora guide, and it's a modified version of Arduino with all of the changes for Flora baked right in. Start by running the pixel test code, and then when that works, you can change it to make any kind of animation or color changing you'd like. The yellow lights on board will blink when your program is uploading, and then your sketch will run, animating colors as you desire. A handy thing is this adhesive pin back that sticks right onto the back of the Flora, and then I can pin it to my shirt or jacket. To power the Flora, we recommend this 3 AAA battery holder. It's the easiest and safest thing to do, but it does leave you with a bit of a big battery pack. So I prefer these rechargeable lithium polymer batteries. They have some extra safety concerns that you should read about in the project documentation, but they certainly are lighter, smaller, and will hold a charge for longer. Just slide the battery into your pocket and use the pin back to attach it to your garment. We're even testing out these teeny tiny lithium polymer batteries that you can stick right behind the Flora. So I hope I've inspired you to get out there and make your own wearable project, and if you do, share it with us in the Adafruit Flickr pool or on our weekly show and tell on Google+. And as always, don't forget to subscribe to our...
All right, that was an awesome video from Becky.
Blinky.
I'm gonna start adding a little bit of a new segment thing soon too, because each person at the company is starting to do different days of the week for their like big thing. So Becky usually has a video, but I'm gonna ask other folks like Matt, who I'm about to go over, just to have like a 30-second overview of what's the cool thing that we showed or talked about on the site. Because I like this, we tried to do the Skyping and thing for folks, and no one wants to hang out with us at 10 o'clock at night on Saturdays.
No, they're partying.
Yeah, everyone's having fun. So we don't. So I thought it would be neat to have the videos pre-recorded. I like playing Becky's videos.
Yeah.
Anyways, a little bit of a coming soon thing. Anyways, we do 3D Thursday every Thursday, and there's 2 interesting things I thought that was in 3D Thursday this week. One was this printable electronic stuff. It's 3D. Printed interface device, and it basically prints out plastic with the traces, so you could make electronics. The other thing that I thought was really neat, if you go to the Make site, they have this 3D printer comparison of all the 3D printers they sell.
It's crazy.
It's a really neat chart. Make is selling 8 different 3D printers right now, and they have a 3D printed guide. They completely stepped it up. So if you're curious about which 3D printer is right for you, and we all ask that question every day, check out the Maker Shed.
Yeah.
They have a really nice chart. Okay. So let me just make sure I got through all of the news, and I did. We have, yeah, I did. We just have one other section that we have to get through. Every week,
Pi Day.
We do Pi Day.
Pi Day.
Yeah, we do Pi Day, and we also had some Pi tutorials. So this week, Simon and you have some tutorials. This is getting started with the Raspberry Pi.
This is how to get your card booted.
Yeah, this is actually one of the hardest things and most requested things. Okay, I've got a Raspberry Pi, now what? Because it doesn't come with anything unless you get one of our starter packs.
Yeah.
And so we show you how to put on Raspbian or Occidentalist. And we also now have Raspbian on a SD card for the folks who just don't want to go through all the utilities and the hassle. Some people can't just download like large files, like 500 megs is actually not possible. So we have that available for folks. And then also setting up the Raspberry Pi.
Yeah.
So when you configure it. So those are the 2 tutorials that we released. Other news around the web for Raspberry Pi that I thought was really interesting. There's the mounting hole template for folks who want to make stuff around the Raspberry Pi.
Yeah.
Plan 9 Unix stuff is now running on the Raspberry Pi. Very cool. And then this is the first Raspberry Pi tattoo.
This guy has a collection.
And this is the same person. So he has Android, Linux, Ubuntu, and Raspberry Pi.
That's cool. I mean, like,
So-
at least he's like, I'm going to cover them all.
Yeah, kind of neat open source tattoos. So far, there's no Adafruit tattoo. I've not seen that.
I think I'm okay with that.
I mean, I have one if everyone would like to see. Oh, no, never mind. This is a kid show.
Do not show them your Adafruit tattoo.
Yeah. Next up, I do have one last
one last thing.
This is a factory photo of where the Raspberry Pis are made.
Yeah.
And guess what, everybody? We have a video. So here is where and how the Raspberry Pis are made. It'll start in a second.
In a little town where I belong, there's a most accomplished fellow. He's the leader of the village choir, and his voice is warm and mellow. He drives a fruit cart around the street, and everybody knows it. He doesn't sing or rave about his fruit, he simply blows it. He's doing it all day long. It's better than any song. Though it isn't very pretty, you've got to admit it's cute. So all together let it go. Eat more fruit. It's certainly come to stay. It's a treat to hear him say, hey, fruits in season plenty there is, apples, plums, and the old raspberries. Everything is fresh today. Every Friday night when work is done, he never wastes a minute. To the village hall he hurries round, where he sings just like a linnet. To hear him blow a melody, it's great, you can't deny it. And if you've nothing else to do, I'd like you all to try it. Get ready and do it now. It's easy when you know how. Though it isn't very pretty, you've got to admit it's cute. So all together let it go. Eat more fruit. It's certainly come to stay. It's a treat to hear him say, hey, doti lasso fa mi vedo. Everything is fresh today.
That's it.
That was intense.
So for the folks out there who don't know what wave soldering is, that last piece, what was that?
Actually, there were a couple things. So the first machine was called a chip shooter. And
Does it shoot chips?
It shoots chips.
Yeah.
And it's not exactly the same as a pick and place. They're ultra high speed, and often they're meant to only place like capacitors or resistors. And so they're optimized for placing small components that don't need intense vision analysis, and they just bang those chips, the little capacitors and resistors out. And then the second step was the package on package assembly, the POP assembly. And so it places the processor down, and then what's interesting is that the processor also has pads on top of it. And so what you do is you place the processor down on the circuit board, and then next it would pick up the RAM, and it places the RAM on top of the processor. So that's package on package. So the RAM sits on top of the chip, which sits on top of the circuit board. So that's a way to save a lot of space, and also it makes the RAM access much faster because there's no traces. You know, it just goes straight up and down, which is really cool. And the Beagle board did the same thing. The Beagle Bone doesn't, but the Beagle board doesn't. And then that's good for surface mount stuff. Then they oven that in the reflow. But then the last thing is, you've got the USB connector and the Ethernet and the plugs and all these. And these are through-hole parts. And so to get these connected, you actually have to have a part that they're placed by hand. A person places them. It's not done by machine. Usually a person places them in. And then they get put on a special jig, and the jig holds the boards and it covers up. everything except the parts that are through-hole soldered. And then it goes over, like you saw, that it's a spinning wave of molten solder. So this is like the most dangerous thing on the earth. It's like for 300 degrees Celsius, molten metal, and it's a little waterfall, a little ripple. And the board passes right over it so that the ripple just wipes over.
Just goes and solders.
Yeah, it wipes it over, and it solders all of those through-hole parts without disturbing the surface.
And it looks like there was like some type of steam or fog or something blowing over this flux.
Yeah,
so it's spraying it over.
Yeah.
Very
and
cool.
then the test, the final test.
I'll tell you what I like, because we're headed in the same direction. I like that the Raspberry Pi folks are posting videos of the Raspberry Pi boards being made from start to finish. It's very nice.
Yeah.
We have a really beefy internet connection that we're getting installed just for showing the different parts of manufacturing at Adafruit.
Yeah.
That's kind of my holiday project. I want to have it set up so you'll be able to see a lot of the things that we're making as we make them. So I like that. Very neat. Okay, we're gonna skip straight to the new products, and then we have a special kind of how-to thing that we did. But real quick before we start, the code is next 10% off all items in stock. If it's in stock, you can buy it. 10% off only until 11:59 tonight, though. So get on it. Here is the new products. New product time. All right, here we go. First up, copper tape.
Okay. So yeah, we've got copper tape by popular demand. People were asking us. We have copper tape in the Dradio kit and also I think in the Makey Makey, but people wanted to get their own. And so this is a lot of copper tape, and we have two. We have thin, which is 6 millimeter, and thicker, which is 25 millimeters. The same exact manufacturer. Both of them are 15 meters worth of copper tape, and this is pure copper tape. So we splurged. We got the real pure copper tape, so it's a little more flexible, it's softer. So that's good. It's also got conductive adhesive on the back. And so that's important too, because a lot of cheaper copper tape that you'll get, especially if you're like, oh, I'm just going to go on eBay and get copper tape for cheap, often it will not have conductive adhesive, or they'll say it is conductive and it's not. So we definitely got conductive adhesive on this, which is good, so you don't have to solder to it if you're placing it on top of a pad or something. And these are really good for stuff like Dradio hacking, Makey Makeys, you want to do a capacitive touchpad. They're really handy. I use copper tape all the time for all sorts of things. You can also, they can carry current. Yeah. They're not super thick, but it will carry current. You can do the calculations for
stained glass.
You can also use it for stained glass. Although this is a little bit too thin and this is a little bit too thick, I think. But you can
little
definitely
tiny
work with this
stained
stuff.
glass.
So you can definitely work with this stuff. So now we have. I think this is it's a lot. You get a lot for your purchase. This is a lot of tape.
Yeah.
This is good stuff.
Okay. Next up. These are handy.
This is super handy. Hold on, let me see where it is.
These are little switches.
It's an inline switch.
Inline switch for all of your electronics.
Yeah, it's kind of. I was actually looking for something different, and I found this by accident, and I was like, this is so handy. I have to have this in the store, and I got a bunch, and then we immediately used them in production, and everyone's like, I don't know how we live without it, because they use it to reset the testers, and like to turn on and off stuff without having to reach behind, like things that don't have switches. So this is. Basically, it's a standard 2.1 millimeter DC jack. So like 99% of your power adapters and battery holders will have this on there. And inline is a multi-amp switch that just basically turns on and off. It's a really nice clicky switch. It's really solid. It's actually meant for a lamp, so it can handle up to like 200 volts or AC or 120 volts AC. But we're using it for DC. And we find it's good for that. It'll probably switch like 5 amps pretty easily. You can use up to 25 volts DC, no problem. And it's just really handy because, for like a couple dollars, you put it between your Arduino and your power supply, and then it has an on-off switch. Or between whatever you've made.
And it comes in Adafruit Black.
Someone
asked, is there ones that have an LED indicator?
I really wish it did, but the problem is it doesn't know what the voltage is going to be, and so that's why. Like often, if you find one with an indicator, it's got a neon bulb. It's for 120 volts.
You would need to know the voltage ahead of time.
The thing is that this was meant for a lamp, so if it had an indicator, the lamp would expect 120 volts. So then when you drove it with a 5-volt adapter, it wouldn't work. So that's why it doesn't have an LED in it. Hopefully, your project has some sort of LED indicator instead. So but still, these are really handy. I stashed like 10 of these. For
Lady Ada approved. Okay. Next up. It's here. We've had these for a bit, but we were waiting to make sure that we had a couple other things. These are the electric imps.
Imp.
And Lady Ada, what the heck is an electric imp?
It's the little imp inside your SD cards. So this is a little SD card. When I saw this, actually, I saw this at Maker Faire, and I was like, this is pretty cool. And so we're getting some of these developer editions, and this is an interesting device. It's a little weird because the thing is it looks a lot like an SD card that you'd put in your camera.
Yeah.
And it's shaped like an SD card on purpose. They did this because they wanted it so you could get connectors really cheap, because that's a common problem when you're designing something. You want something where the connector, you don't have to make a custom connector. And
like XP needs an XB shield.
Yeah, it's a little annoying.
Yes, but this, just you use an SD card holder to interface with
Which
it.
I think is actually quite smart. And the SD card pinout there's 2 ground pins, and so this actually only uses one of those ground pins, and it detects whether that other pin is also grounded. And if it isn't, it turns itself on. So even though it's SD card shaped, it will not work in anything that uses an SD card.
You put it in, it just doesn't work because it's looking for like, oh, hey, I don't got anything there.
It needs to be a special socket. It needs not a special socket, but it needs a special connection. It's like pin 8 or something. It has to be connected higher through a 10K resistor or something. Anyways, so you know, just SD card shaped, but you can't put this in your camera, and you can't put this in your MP3 player. It'll magically work. However, we do have a handy little breakout board for it. And so what happens is that
called the April.
This board, if you've ever used an iFi card, it's kind of similar. Inside is actually a Wi-Fi chip. And if we took apart one of these, Kevin came over, K-Town was in town, and we took one of these apart. And we'll put photos up of the inside, which is really interesting. So it's an SD card, and inside is a Wi-Fi adapter and a little microcontroller. It's like it's a Broadcom chip and then an ARM core. And what it does is when you power it, you can program it to look for Wi-Fi, and it'll go to the Electric Imp website, and you can register a firmware that it will download and run on it. So it's basically like a little Wi-Fi enabled microcontroller that you program it through a web interface. So this is kind of cool because what you can do is you can have your project, like it's also like super low power, and it's designed to like be embedded in something. So what you can do is you can have your little Electric Imp projects. Let's say you had a solar powered temperature sensor or something, and it's on your roof, right? It's a barometric pressure sensor or temperature sensor. So instead of if you want to reprogram it, instead of going upstairs, grabbing the box, bring it downstairs, plugging in your JTAG, writing your code, and reprogramming it, instead what you do is you go to the Electric Imp website, and you use their web software, and you say, hey, this card ID number XXX is mine, and on the back it has like the unique MAC address, and that is unique to every card. And then you say, hey, for that card, upload my new code, and the Electric Imp will automatically know to go to the website, get the latest code, update itself with this Wi-Fi bootloader, and it'll run it. So it's a little processor with Wi-Fi built in that you upload wirelessly. So it's very powerful, and I think it's very interesting.
Yeah.
And I think for a lot of projects, the really killer thing is that it's really cheap. It's $30. So that's the same price as like a Wi-Fi adapter.
Yeah.
And it has the processor built in, and it's a fairly good processor. It has all your things that you like SPI, I2C, analog digital converter.
What do you code in for this?
They say it's like Squirrel. It's a C-like language. It's something like C. It's not too weird. It's scripting-esque, but it's powerful.
You can check out the Squirrel. There's a Squirrel resource wiki thing.
Yeah, you check out their website. I think for what it's really meant for is because it's you're buying one for $30, and the idea is that let's say you wanted to make like a Wi-Fi light bulb or something. Yeah. Or like a Wi-Fi a Christmas tree light setup. You could have, you could manufacture it, and every one of these would have a card in it, and the price wouldn't be prohibitive. And then instead of having like Bluetooth and you have an app and it's weird, it would all run on Wi-Fi, and it's very easy.
So you can just pop it in, and like the code goes down. It's cool.
It's basically I like it because it's very fast and easy. Like it's not, it isn't a fully open source system.
Yeah.
It's you do have to use their website. Yeah,
it's like iFi. It's not an open source server that goes with it, but the value of it, if you're interested in it, that's where it comes from.
I think for people who are doing one-offs, especially, like if they just want it to work and run, I think that there is a lot of value to that. So I thought it was an interesting development board for to carry. And so we also carry the April, which is the dev board that they've designed for it. It's really well designed. And I was like, well, I can't really do a better job than this. So I just asked them, hey, can we pick up these dev boards from you? And so we carry them, and they break out all the pins, and then you can power it from battery. and has a really nice high efficiency buck converter, which is really cool.
Okay. All right, we got some more.
It's not as detailed, and for more info, check it out the electricimp.com website. But that's a lightweight.
Yeah.
We'll do some cool projects with this as well. Of
Okay,
course.
next up, we're going to be a couple of minutes late on the show this week, so
Well, I have to
we're just
explain this
this is good. We have a lot of stuff.
The imp was
So we've
detailed.
got HDMI monitors for things like the Raspberry Pi.
Yeah, we actually sold out, but I want to
Yeah,
show
we
this.
sold these really fast, but oops, let's go to the overhead. So
I
here it
wanna
is, an
show this.
HDMI.
It's super high res. Well, yeah, you can see.
Yeah.
So you can actually read this text. It's very readable.
Yeah.
And it's only 7 inches, but it's very readable. And we've got VGA, DVI, and HDMI, and then it runs off of like a 9-volt adapter. And then if you hold on 1 second, I can log in. And I just like this because it's a much higher resolution than our. We have an NTSC 7-inch, but this is much clearer. So let me start up X so you can see. It's pretty high res. I think it's like 10. It's like 10 by 7. It's like 1,000 by 700 pixels. It's definitely like high res. Like actually, when we were like installing a computer, I used this as a monitor.
Yeah.
And it's hard to tell, of course, through a screen, the video cam, but it's super crisp screens. Actually, I tried out like 4 or 5 different HDMI monitors, and this one was the clearest by far. Very crisp, looks good. I tried it with VGA as well. It looks really good.
Yeah.
So we'll be getting more of these. It's a really fantastic little addition, and then there's some mounting holes on the back if you want to attach it.
Next up, this is like one of my favorite new products we have. Black.
This took me many months to get.
Black GPIO cables.
I had to order a lot.
Yeah, this really is an Adafruit black. I wasn't kidding earlier.
No, we custom ordered
Yeah.
this with black with a white stripe.
We wanted to have really high quality GPIO cables for Raspberry Pi stuff, and because we ordered so many of them, we said let's get them in our color, black, and so we have them now.
Painted
Do you need-
black.
Okay.
I'm
I'm just going to
anything.
keep.
Yeah,
keep
yeah,
moving on.
it's
Now we have these little remotes, and then we're going to show a quick video. Then we're going to try to show a
I
project.
just want to show the remotes
Yeah.
on here, and then the video is actually
Yeah,
really good.
I have a video. Becky made a fantastic video.
So I
we have
just want to
these
show how
little-
big it is.
Yeah, this is the remote. This is the receiver, and it controls stuff.
Yeah, so let me just show this receiver on the overhead really fast. Can you go to the overhead?
Yeah.
Okay.
Go on there.
Let's get there. So these are little receivers, and this is kind of interesting because we have like XBs, and XBs are like bidirectional, like 2.4 gigahertz lengths. So the thing about this receiver is it's very dumb. It's actually just a coding. It's a fixed code receiver. So this little chip has an antenna and then some parts, and then there's these pinouts, and you give it power and ground, and the power is like 5 volts, and then there's 4 pins, and they're all outputs. And basically, you can either drive the outputs high or low, and that's all it does. There's no like baud rates. There's no setting like transmission speed. There's no nothing. There's no addressing. It's very, very simple. But that makes it really powerful because you don't need a microcontroller. So for example, for the demo, and this is the same setup we have for the video, there's no booting, there's no code upload, whatever. I just power it from 5 volts, and then the remote control just works. So if you just want like a project where you're like, well, I just want to turn something on or off, or you want to signal to your Arduino, or you want to signal to your Raspberry Pi or whatever using an RF remote. So this is a 315 megahertz remote, I think, or something, or I don't remember the exact frequency. And there's 3 different types, and we'll show the little video. But I just want to show that there's no microcontroller required, and you don't have to use one. These are actually used for like garage door openers and stuff like that, or like AV systems. You can use it with a microcontroller because it's this 5-volt output, and you could use the resistors to divide it down for a 3-volt micro. But it's not bidirectional. It's only from the remote to the receiver. This guy does not transmit at all.
Okay.
Only this transmits. All right, so let's see the video so you can see the difference between the 3
Will
types.
this work with the power switch tail?
This will work great with this power switch shell.
That's an excellent project.
That's right.
George Graves mentioned that. All right, let's watch the video. that is new products for the week. Whew, okay. So next up, we have a special project. We have a special project that we did for the folks that have heard this clacking on the keyboard.
I don't know if they can hear it because the microphone.
We have a good mic, but there is clacking. So this was a special project that Lady Ada and I worked on together. I'm a fan of Next computers. These are really old from, the 90s. And
mid-late 90s.
Late 90s. And I have a collection of Next hardware, including a Next keyboard. And if you notice, there's a new thing connected to it. It's a Mint tin. And this is the Arduino Micro that was also on the back. It has our logo, co-designed by Adafruit. And it can act as a keyboard. And so one of the things that we did...
Actually, sorry, no, late 80s, early 90s.
Yeah.
Not mid-late 90s.
I'm getting old.
Yeah.
So anyways... this is my Next keyboard, and it's in really good condition. And I wanted to use it with a modern computer, but they did something different than ADB.
This was before ADB. I don't think ADB existed at the time.
Well, you know, Next was kind of trying to do their own thing. By the way, this is a mint condition Next mouse. So I have a collection of Next gear. One quick thing I'm going to show. This is something we're taking apart and doing something with right now. This is the Next sound box. It's a little cube-like thing, but there you can see on the inside. But it's a little triangle that fits on your desk. But anyways, this is the Next keyboard, and I'll go to the overhead real quick, just so you can see. And this is attached to my Mac. So what I want you to do is make some history here, Lady Ada. When you type, you're typing in the chat.
Is it working?
Yeah, type hi, and then hit enter. All right, so this is the first time in history.
I also showed I did this really cool thing with the shift.
Oh,
so
look
when
at that.
you press the shift button, the LED lights up.
Yeah, so this is using the Micro, pretending to be a keyboard. And because it was non-ADB, you had to hack this thing and figure out this protocol. We found this documentation from Japan that some guy started. And then here's the non-ADB. This is the this is the way they did it.
It uses like it's basically a serial interface. I mean, it's not like serial as in like a TTL. I mean, it's a similar type. It uses 50 microsecond timing, and you just have to do this sort of query response thing. And luckily, this fellow from Japan did some timing diagrams, which was really helpful. I mean, it took me most of the time I spent just trying to figure out like if anyone had documented this, and I was looking through all this like kernel code and.
Listen to that action. Isn't that great?
So once I found it, though, that actually made it not so bad. And then we used a Micro, and I thought this would be a really good project for using a Micro. And then we fit it into a gum tin. So it fits very nicely, and it looks kind of cool because it's silver. So
there's really old keyboards out there that have different ways that they worked. And so what we wanted to show is how cool like the Arduino Micro is, that you can turn it into a keyboard that can do these types of things. Now we could, if we wanted to take this project further, we could plug in this non-ADB mouse into the back of the keyboard.
I could make it work.
And make it turn into a mouse.
But it's like an old rolly ball.
Yeah, it's a roll. I don't want to clean out all this stuff. But so I'm just going to go ahead and put this back into the museum category. But what a great keyboard. This was my favorite keyboard of all time. It's loud, it's clanky, it's solid, it weighs like 5 pounds.
I did have to open it up because I wanted to make sure that I had the pin out right, and so I opened it up to look at the circuit board traces, and it is like there's like solid steel chunks inside.
Yeah. So that was the project that we put up on the Learn system. You can
go check it out.
You can check it out. It's making the rounds online. It hits Slashdot and some of the kind of geek-friendly sites, I'd say.
Yeah.
And if you like the old Next computers, you know, the World Wide Web made on a Next computer, a slab. Sorry, it was a cube. I believe that's it was in the Computer History Museum or wherever the original one is. I forgot exactly where it exists right now. During the opening ceremony of the Olympics, they had Sir Tim Berners-Lee typing on a Next, tweeting. So we could actually tweet with a Next keyboard right now if we wanted to. Okay. So we're not too much behind. We're right at the 11 o'clock mark. So let's Let's do some speed questions for a couple minutes, and then we'll do. Then
the
we'll.
cat go?
Yeah, he's hanging out. He's asleep.
Okay,
Yeah,
he's
we'll do
looking
some.
back.
We'll do some quick questions.
He's sleeping. He looks cute.
Yeah, what does Adafruit use for their bill of materials manager? Boom.
I use
The
Excel
bomb.
for like a project.
Excel is what we use.
Or Open Office or something.
Yeah, sometimes we use Google Docs with the spreadsheet stuff.
Yeah,
when we're-
something where we have to share it.
Yeah. Okay, will you be redesigning the data logger shield to use the R3 pins and be hardware SPI compatible on the Mega Leo?
We do have a version of the data logger shield, but it won't be using hardware SPI, but I rewrote the SD library to support any pin configuration, so you won't have to edit header files. But it will be R3 compatible.
Okay.
But there's a trade-off, because like not every Arduino has pins in the SPI location.
Will there be a tutorial for button snaps on the Flora? Yes.
Yes.
Yeah. How long did it take to develop the Flora?
It took like a month or two of revisions and stuff. It took like 3 or 4 revisions. But,
Yeah, and
you know,
then
a lot of the time was spent sourcing. Like I wanted to have these pixels, so I had to spend a lot of time figuring out how I'm going to do that, and then finding the right GPS. That took a really long time.
Yeah.
So more of the time was spent on the accessory stuff.
Basically a year. I mean, like all together with everything we did, and then we did testing, and then there was a lot of stuff changing in the Arduino world that we had to keep up with.
Yeah.
And then we wanted to make sure it was good.
Yeah.
So about a year. Next up, a switch tail for lamp dimming.
No, the power switch tail is only for on or off.
All right. Are we going to start doing tutorials on a new Due?
I don't know if I'm going to have time to do tutorials on Due, but I definitely got the LED strip working on Due today because people were complaining about that, so that got done. And but you know, the Due is, I think that I'm going to, it's still in beta. We're going to wait to see what people want to do. I don't have any projects that need something like that.
Yeah. If we can get a gauge of what people want to do with it, and if people buy a lot of them, of course, that motivates us to do tutorials too.
Yeah. But it's an advanced board, and so people who get to that point usually they have something so custom that you don't need to start getting started tutorial.
Yeah.
Most people don't get started with a Due.
Is the Adafruit product 372 10K thermistor okay to be fully immersed in water? If not, what is the best way to make it work?
You can put it in water, but the best thing to use for waterproof stuff is we have a digital temperature sensor. Those are like really waterproof.
Okay. Will you ever build boards that support the TI Launchpad devices?
I haven't played with Launchpad. I don't see why not, but I don't have one yet.
Okay. Any plans to carry some base platforms for the Arduino or Pi-based robots? Yes, we're working on some.
Is base? Is that what I mean?
Like what it would fit on a base and then have
Oh
wheels or
yeah,
something
yeah.
like that,
We're evaluating a whole different
Working on
bunch.
it.
Yeah, we have to make sure it's a good one. I don't want to carry a crummy one.
Any plans for another NFC board?
No, I think the
Okay.
NFC board we have is like the kind of the best NFC chip on the market.
Okay. Let's see. A hot flasher uses 2 connectors, one on the outside, one on the inside. From what I judge, do those connectors that make it trigger on the flash? That's a John Junior question.
Yeah, I don't know.
John doesn't know that one.
Flash triggers.
Phil, if you need next step for color turbo station, let me know. I got it from Apple before they officially took it off support. Ooh, okay. I may take you up on that after I dust off some, hopefully future.
Do you have a color turbo station?
I had one, but some of my next collection didn't quite make it, but I'm slowly rebuilding it. Finding all the old software is really hard.
Yeah.
Anyways, I do like the black and white stuff though. I mean, that was anyways. Next up, does cold temperatures affect OLEDs?
I'm not sure, but check the OLED datasheet. It should have a operational temperature inside the datasheet. Tell you what works well. But I think it doesn't affect it as much as an LCD.
Yeah. Will you ever be a distributor of the open beam 1 meter lengths?
That's a good question. The problem is it's very hard to ship 1 meter lengths.
Yeah.
So we did talk to him about it, and he's like, well, like it kind of sucks to ship them around, and we have to package them because they're so long, and like UPS doesn't like to ship long, thin things, and like you have to get these tubes, and so we have to figure out a way to do it where the shipping cost. Because the problem is at this point, like if you order $20 worth of open beam, the shipping is $20 too, and so we have to figure out how we're going to do that. So we're thinking of maybe carrying extrusion only in half meter lengths, because half meter is actually much more manageable. You can get boxes that are half meter, and it's not as threatening to UPS and DHL and FedEx and the postal service is like 1 meter length.
Next up, will there be a tour of the new factory? Yes. Today I was actually running Ethernet cable above our code-compliant, expensive ductwork to better be able to walk around and have really great internet access. So if I want to walk around with a mobile setup, that I could show you all the factory. We're working on it. We want to. Hurricane Sandy did set us back on some of our goals for getting ahead as far as like putting some cameras into the shop and doing stuff. So we're getting there. Then we got hit with the holidays, and here we are. The answer is yes. Next up, could you make a TI TMP 006 non-contact temperature sensor breakout board?
We already have one on the way.
All right, there we go.
No estimated time arrival though. It's flying here, but it's a long flight.
And someone really loves the open beam kit we carry. Thank you.
I love it too. I wish we could get more. We're going to be carrying more extrusions of different sizes and plates and stuff. So definitely, I love extrusions. And so now that we have warehouse space, we'll carry more.
Yeah.
We should get the question.
It's now trivia question time. Thank you for all those great questions, folks.
Okay.
We just had a lot of stuff to say. Whew. Okay, it's trivia question time. You know, I can tell there's a graphic. There you go. It's trivia question time.
Yeah. What's the prize?
The prize is going to be a Arduino Micro.
Ooh.
Yeah, an Arduino Micro. We're going to give away an Arduino Micro. So, are you ready?
That's like the starring guest of the show.
Yeah. Okay, so you ready? Whoever types this in first is going to get it.
Oh.
Here comes the trivia question.
Okay.
This is the next cube. What material, what element is best known to be on the outside of the next station, the next cube? They use a specific thing, specific material. Oh, baby wrestler. Magnesium is right.
Forgot to say the rules. We went straight forward. That's okay.
Baby wrestler did not ever win. I would have remembered Baby wrestler's name. So this is the 1 foot by 1 foot by 1 foot cube magnesium.
Not metric?
No, magnesium cube.
You'd think they would have like.
Yeah.
Yeah, you know.
And if you Google around for magnesium cube, there's this big story about like one of them got on fire or melted or like some crazy stuff. So it's a really long story.
Well, it's hard for it to accidentally catch on fire.
Yeah, it's a long story.
We did it on purpose.
So baby or Babby wrestler.
Email support at Adafruit.
Email support at adafruit.com.
I'm going to pick up the sleeping cat.
Yeah,
he's sleeping. So
please get the cat. I'm going to.
It's extra enjoyable to wake up a sleeping cat.
I'm going to type really close to the mic so you can hear this beautiful sound. See, that's what a keyboard is supposed to sound like.
He's totally asleep.
Yeah.
Let's see if you can hear him purring.
Yeah. All right.
Purring?
Yeah. I don't know.
Quiet.
It might be able to. Yeah, he just woke up. Hey, little guy.
He's a little tired.
All right.
He's like, why did you bastards wake me up? I was sleeping. That was my 4th nap.
Okay. We're going to go to sleep. We're exhausted. Thank you, George, for doing the recording. Thank you, everyone, for showing up. Thanks, Paint Your Dragon, who's out. Thank you, John Janier, who's out. John Janier doing a lot of time in Adafruit. He's setting up our new photo studio. Very exciting. Thank you, Colin. Okay, the cat knocked over the mic. This is why we can't have nice things.
Cat.
Yeah. All right. That was loud. Thanks to all the folks that were in the...
Bad cat discovering gravity.
Yeah, thanks for all the folks that were in the chat. Thanks for all the folks in the show and tell. Please join the Adafruit communities that we just opened up on the Google Plus thing.
Yeah.
And another great week in the world of electronics and sharing and learning.
If you want to pick up something as a gift from Adafruit, we do have our shipping schedule. We forgot to mention it, but we have our shipping schedule up. Check it out because deadlines are soon approaching where if you want something and you want to save on shipping, you should order sooner than later.
Yeah, and this is what cut and paste sounds like. Isn't that a sound? Listen to that sound. It's great. It's gratifying.
You want to just paste again?
No.
Can I paste again?
What?
Command V.
Yeah. Do you want to hit enter? Oh, wait. No, don't do it yet.
Don't.
Yeah, now go ahead, hit it. All right. Okay. Okay.
Okay.
See everybody next week. Here is your moment of Zener.